So the title of my talk is Studying Our Earth with Navigation Satellites. So the NASA and other space agencies, they not only look in the outer space, but from the space, they look on our beautiful planet Earth as well. And they have developed a lot of satellite missions to study the Earth, the crust of the Earth, or the oceans, or the atmosphere. But today I will not be talking about those specific satellite missions, but I will be explaining how navigation satellites are used to study the Earth. So I will begin with an overview of Global Navigation Satellite Systems, GNSS, and we'll go through some applications of GNSS in earth sciences and in atmospheric sciences. I will not go into too much mathematics or details, but I will give a brief overview of what can be done using this technique. And then finally, I will talk about something from the Quranic perspective. So what is a GNSS? GNSS stands for Global Navigation Satellite System. So any GNSS is a collection of satellites that is orbiting the Earth, like in various orbits, a large number of satellites divided in different orbits and having a global coverage. So the basic purpose of these satellites is that a point on the ground, it can, using the distance from the point to a specific satellite, it can estimate its position anywhere on the globe. So these satellites, they are about like 20,000 to 23,000 kilometers above the surface of the Earth. So do we use GNSS in our everyday life? If we think for a moment, we will know that yes, we do use GNSS and almost daily. So the handheld smart devices used for navigation, especially like in Apple Maps or Google Maps, or the navigation systems in our cars, they all are using GNSS satellite data to estimate positions. And on the right side, you can see there are some chips, which are GPS antennas and processors, which are used in such handheld devices. So every modern device has a GNSS receiver and antenna embedded into it. So there's not only one GNSS, but there are 4 GNSS. So GPS, or the Global Positioning System, which is the most widely known and widely used GNSS, it belongs to the U.S. Air Force, and it was its development started in 1970s, and it achieved its full operational capability in 1995. Then there is the Russian counterpart, which is called GLONASS. It also became fully operational in 1995 and being modernized continuously. Then there is the Chinese system, which is expected to be fully operational in 2020. And then the Galileo, which is the European Union GNSS. It is expected to have a full operational capability this year, by the end of this year. So the constellation on the left, it is only the GPS constellation. So you can imagine that if we add a similar number of satellites from the other 3 systems listed in the table as well, so how it will be a great improvement in the number of satellites and in the coverage, and eventually it will lead us to more accuracy in our positioning. GNSS, as many of us know, widely known applications are aircraft navigation and landing systems, the road traffic navigation systems, maritime navigation, and timekeeping. So GNSS satellites have some atomic clocks on board, so they are used as a very accurate timing reference. But this doesn't end here. The applications of GNSS, there are many other applications of GNSS as well, which are not very commonly known, and that's why I chose to talk about these today. So as I showed you that in our handheld devices, there are chips which are small, which are GPS which are low-cost chips having GPS processors embedded in them. Because they are low cost and they are not that sophisticated, they cannot give us very good accuracy. So the positioning accuracy for those is up to meter level. So like 1 or 2 meter uncertainty in the position using those low cost devices. But there is another class of GNSS receivers and antennas existing, which is way more sophisticated. They are they are more expensive as well. And because of their sophisticated data processing and signal acquisition, they allow us to estimate the positions with centimeter level accuracy or sometimes millimeter level accuracy as well. So these antennas and receivers can be mounted on the permanent points on the ground or on buildings. They can be flown on aircraft and on satellites, and they can be floated on buoys or ships as well. Okay, but what do we do with these? What's the benefit of this? So the picture, you can see a ground-based GNSS station. The photographs here. So these are the GPS stations, GNSS stations with an antenna, a dome, and a cable going to the receiver and the power system. So such permanent stations are spread all over the world. And as of today, there are thousands of such permanent GNSS stations, and the data from those stations is available freely for research and scientific purposes. So what scientific products we get from these networks is the high accuracy positions at each station location and high accuracy velocities of each station. And then it comes with very high temporal resolution. We can use precise GNSS to estimate position every 1 second as well. So you can imagine if we know the precise positions of so many points on the Earth in a higher timely resolution, we can do a lot of it, a lot using it. We can estimate the atmospheric refractivity and water vapor content through GNSS as well. So some applications of GNSS in earth sciences, they include the studies of plate tectonics. We can see how tectonic plates are moving. We can use GNSS to improve our studies of global sea level rise, which is a high concern due to global warming. We can improve the predictability of earthquakes using GPS data in combination with seismometers. And we can develop tsunami warning systems using GNSS as well. Then in atmospheric sciences, GNSS can be used to improve the quality of weather forecasts. That's what my PhD was about. So we can monitor severe weather events, and we can improve the prediction of cyclones, and we can study climate variability as well. So as this verse has been quoted in many earlier presentations as well. So we are the Ummah of Muhammad Sallallahu Alaihi Wasallam, and it's incumbent on us to do good for the mankind. So associating myself with this field of research, I feel that I am doing something good for the mankind. And there is a lot of wisdom available in the Quran as well. We can study the geophysical process. We can obtain guidance about geophysical processes from Quran and try to prove the hypothesis. Okay, I will end here since the time has gone up. Jazakallah.